All right, we are going to do some more factoring in section 4.4. If you notice, these are a little bit different because you have a number in front of the x squared that is different than 1. Okay, but we're still going to use the same method. I'm going to make the double bubbles. Okay, now I think about the factors of 8. You've got 1 and 8, you've got 2 and 4. And at this point, it's really just kind of a trial and error. I'm going to go ahead and use 2x and 4x. Those are the factors of 8x squared. Now your factors of 9, okay, you always take the first and do the factors, and you take the last and do the factors. So the A and the C, okay? Now factors of 9 are 1 and 9, and 3 and 3. I'm going to try 3 and 3. Now, when I multiply this out, I have to get an 18x in the middle. So here's how I do this. I look at the middle. You think about this is the I in FOIL, okay? And I also look at the O in FOIL. So I'm looking at the outside and the inside. Inside, I have 12x. Outside, I have 6x. Will that give me 18x? And this is a positive 18. Yes, it will, as long as both of these are positive. And then to just double check your signs, this is a positive 9. Positive times a positive would give us a positive 9 at the end. Okay, so if you were to FOIL this back out, you should get back to your original. So this would be the factored form. This right here would be the factored form for that expression. Next one. Again, think of your factors of 10. Start with the A. Okay, you've got 1 and 10, 2 and 5. Let's try 2x, 5x. Then you look at your factors of C. For 6, I would go 2 and 3. Now this could be a matter of placement. If I put the 3 here, I'd have 15 in the middle. And then a 2 out here would be 4 on the outside. 15 and 4 does add up to 19. So again, double check. Inside, we'd have 15x. Outside, we'd have 4x. And since I need a negative 19 in the middle, these would both have to be negative because I need a negative 15 and a negative 4. Okay, and then double check the signs. Negative 3 times a negative 2 would give me a positive 6. So that would be the factored form for that expression. One more. Again, look at the factors of 18. Okay, now again, this is kind of a trial and error at this point. Factors of 18 would be 1 and 18, 2 and 9, 3 and 6. Really just a matter of choice right now. What if I started with 2n and 9n? Then I've got my factors of 14, 1 and 14, 2 and 7. So if I started with, let's say, 2 and 7, inside I have 18, outside I have 14. Well, that's not going to work, okay? Now you could try some different things here. You could switch the 2 and the 7. You could switch those around. Well, 7 times 9, that's going to be huge, so that's not going to work. My bet is that we're going to need to change the 2 and 9. So let's try 3n and 6n. And then factors of 14, I'm still going to go with 2 and 7. Let's try 2 here, 7 here. Inside, I have 12n. Outside, I have 21n if I multiply those. Now, this will give me a positive 9 as long as the 12 is negative, okay? And this is what I do. The inside, okay, this inside little loop, that sign is always going to go to the left. So this is going to be negative, and this is going to be positive. And again, you can double check. 2 times 6, that's the 12, so that's what needs to have the negative. And then we need a positive 21, so the positive has to go with the 7. Okay? So this is the factored form for that expression. Now from here on out, you do need to check to see if you can factor out a monomial first. Remember, a monomial is one term, okay? If I look at these three terms in this trinomial, what can I take out of all three of these terms? I notice that I can take out a 3. So I'm going to bring that 3 down, and then we put parentheses. What's left in this term if I take out the 3? Just x squared would be left. Now I look at this term, okay? We're going to bring the plus sign down. How many times does 3 go into 54? Or think of it as 54 divided by the 3. Well, that's going to be 18. So this would be 18x. Okay? And then we'll bring this plus sign down. And now the last term, if I take 3 out of 243, or 243 divided by 3, that would be 81. Okay? So that is factoring out this monomial. 3 is the monomial. That's factored out first. Now I'm going to carry down the 3, and I'm going to see if I can factor this any further. Now this goes back to having just a 1 in front of the x, so this one's a little bit easier. We've got x and x, and you can just think factors of 81, that'll add up to 18. Well, that would be 9 and 9. And they both need to be positive because the 18 is positive, and two positives make a positive 81 when you multiply it. Another way to write this could be 3 times x plus 9 squared. And either of these two answers would be acceptable. Next one. If you notice, this one has a negative in front of the y squared. Whenever you have a negative in front of the y squared, factor that out, because it's always a lot easier to factor if you take out this negative, because you want the y squared to be positive. And if I look at all of those numbers, I can also factor out a 5. So I'm going to factor out negative 5. When I do that, if I divide this by negative 5, I'd have positive 5y squared. Okay? Now what happens when you factor out a negative? This sign is going to change. Because think about, if I were to distribute this back out, negative times a negative gets me back to this positive. Now how many times does 5 go into 60? 12. So this is going to be 12y. And again, since I took out a negative, that sign has to change back to positive. Negative times a positive gets me back to this negative. And then 5 goes into 35 7 times. All right, and let's see if we can factor that any further. Bring down the negative 5, double bubble. Okay, factors of 5, our only options are 5 and 1, so I'm going to do 5y and 1y. Factors of 7, my only factors are 1 and 7. I'm going to put the 7 here and the 1 here, because if I look at the middle, that's going to give me 7, and the outside is going to give me 5. So if I want a negative 12, I've got to have negative 7y and negative 5y. So that gives me the negative 12 in the middle. Negative 7 times negative 1 is positive 7. So that would be my final factorization for that expression. Now let's go to solving the equation. And like I said, from here on out, you always want to make sure that you factor out any monomials first. So look for that. And just like we did before, make sure that you have equals 0 on one side, okay, which we do. We have equals 0 here. Can I factor out a monomial with 5, 3, and 2? I cannot. So I would go straight to factoring double bubble. Okay, factors of 5 again are 5 and 1, so I have 5x and 1x. Factors of 2 would be 1 and 2. I'm going to put the 2 here and the 1 here because I want 5 and 2. If I go negative 2 and positive 5, That'll give me the positive 3 in the middle, and a negative times a positive gives me a negative 2 out here at the end. And that still equals 0. So just like we did before, I would set both of these parentheses equal to 0. So I've got 5x minus 2 equals 0, or x plus 1 equals 0. Now we solve both of these. X is 2/5. Okay, there's one answer. Or x is negative 1. So I have two answers. And if you notice, this 2/5 down here, it's always the opposite of what's inside the parentheses, and it's going to be this number over this number. Because anytime you have to set this equal to 0, you'd have to add the 2, divide by the 5. So it'd be positive 2/5. To solve this equation, we have to get everything on one side. And I'm going to do this all at once. I'm going to bring this whole side over to the left. So I'm going to subtract 2x squared, add 8x, and subtract 1. So I'm bringing this whole side over to this side by going opposite signs. So I'm going to end up with 6x squared plus 13x minus 5 equals 0, because I brought all this over to the other side. Can we factor out a greatest common monomial? Okay, 6, 13, and 5, there's no common monomials to take out, so I'm going to go ahead and double bubble. Factors of 6, let's try 2 and 3, 2x and 3x. And then our factors of 5 are 5 and 1. If I go 5 here and 1 here, I'd have 15 in the middle, 2 outside. And if I need a positive 13, it'd have to be plus the 15 inside minus 2x outside. And the positive times the negative gives us the negative 5. Now, if I use the rule that I showed you before, you can set both of these equal to 0, or you can think opposite sign. So this is going to have to be negative, and then it's going to be 5 over the 2. So negative 5 halves would be the answer. X would also be opposite sign, so it would be positive, and you take this number over the number in front of x. So it would be positive 1/3. And again, you can certainly go ahead and set these equal to 0. Again, you'd add 1, divide by 3, so you'd end up with positive 1/3. So when you're finding the zeros, you're actually finding the x-intercepts of the graph. And if you think about the x-intercepts when they cross the x-axis, that's when y is 0. So really you're thinking about when you have 0 over here for the y, that's really no different than the problems we just finished. Y equals, is there a monomial that I can take out of here? There's not, so I'm going to go ahead and double bubble. Factors of 25, I would probably say 5 and 5 is a good guess. Factors of 24, we have quite a few of them to choose from here. What if I tried 6 and 4? If I went 6, that'd be 30, and 4 would be 20. So let's go with that. We got 6 and 4. Positive 30 minus 20 would give me positive 10 in the middle. Positive times a negative gives us the negative 24. So my zeros, again, think opposite, so it's going to be negative 6 over the 5. And then for this one, you think opposite, so it'd be positive 4 over 5. Okay, so those are the zeros for that function. And that concludes section 4.4.